Okay, now we're going to take a look at page 68 of your workbook and find the perimeter and area of this shape. We have a couple of different shapes that are put together. It's probably a good idea to read through your textbook first and then make sure you're familiar with the formulas and things. So for perimeter, we're just going to add up all the sides, but we don't know all the sides to begin with. So first one we're going to look at is we need to figure out what this shape here is, or this side is. And to do that, we need to know this dimension. Now it kind of looks like, oh, it's about halfway through, but it says the shape is not drawn to scale. So we can't really count on that or even measure. But we can use the Pythagorean theorem. We know this comes down at a 90-degree angle, so we know this would be the hypotenuse. This base of the triangle we also need to know, not only to use the Pythagorean theorem, but later that will help us find the area. So what we're going to do is be looking at calling this side A and this B. We can figure out the length of side A by knowing that the base of this rectangle will be the same as the top, and that will be 4. So that leaves A to equal 3. To find B, we're going to use the Pythagorean theorem. And I'll write that out. Pause the video and see if you can do that along with me. Now you can see over to the right where I have worked out the calculation for the length B. Comes out to be 4 yards. So that leaves us with 2 yards for this missing side. Now we can figure out the perimeter of the whole shape. So perimeter, we're just going to be adding up the sides. So we have this dimension 6 plus the top of the rectangle is 4. The 2 for that piece. Make sure you don't include the 4 below. There we go. On the hypotenuse of that rectangle is 5. And then the entire base is 7. I'll go ahead and calculate that out, and we'll get 24 yards. Perimeter is in just linear units. Now we're going to work out the area. We just need to add up the area of the large rectangle here and the triangle. So we're going to have 6 by 4 triangle, length times width, plus half base times height for the triangle. So our base is just the 3, and our height is the value 4 that we found by the Pythagorean theorem. Go ahead and calculate following order of operations. And we get 30, and that is in square yards. You can use this notation, yards squared, if you like. Okay, now we're going to take up with page 70 of your workbook. We have a shape that has a semicircle and a rectangle. You can split it up. You can find the radius to be half of this base. So radius is 10. You can find the perimeter or circumference of the semicircle would be half 2 pi r, so the half of the circle, and the perimeter of the rectangle is going to be just adding up the sides. 42 plus 20 plus 42. So if we fill in up here, these will reduce out. So we just have the 10 pi. Pi is about 3.14. Then we have 31.4. We'll just round off. We can add that to our perimeter here. So the total perimeter is going to be 84 plus 20, 104, plus our 31 will give us 135. And that will be linear units, inches. Now we're going to take a look at the area. And we want to use the area of the circle. But again, it's only half circle. So it's going to be half pi r squared. And then plus the length times width, or base times height, however you want to look at it, of the rectangle. So we'll have half of times 10 squared is 100. And then we have 42 times 20. Go ahead and pause the video and work the math out on that. So now, working out all the math, we will get 997 square inches. Notice I used a wavy equal sign to show approximately because I did round that 157. If you keep getting pi on your calculator using the multi-view calculator, go ahead and hit the little double arrow toggle switch above the enter symbol, and that'll transition you back and forth from decimal to radian form. Same goes for fractions. Now we're taking a look at example 6.15. I'm going to leave this one for you to do on your own, but with a hint for the area, you do need to find what this height is of the triangle, and you can use the Pythagorean theorem. Thank you for watching.